Hello and welcome to Algebra 1, Chapter 6.2, and today we're going to be solving inequalities using multiplication and division. So starting out with some properties, our first one says that you can multiply each side of an inequality by the same positive number and it will remain true. So for example, if you agree that 2 is less than 6, if I multiply each side by 2, we're going to get 4 is less than 12, which is still true. Okay? For the second property, you can multiply each side of an inequality by the same negative number if you reverse the inequality. Key thing there. So what happens if we multiply by a negative number here? So if we have 2 is less than 6, and now I'm going to multiply each side by a negative 2, we get negative 4 is less than negative 12. But negative 4 is not less than negative 12. Negative 4 is greater than negative 12. So for this inequality to remain true, we must reverse our inequality. So if you multiply by a negative, reverse your inequality. So that really gets to be the only difference between solving an equation and solving an inequality. So Bob walks at a rate of 3/4 of a mile per hour. He knows that it is at least 9 miles to Onks Lake. How long will it take Bob to get there? Write and solve an inequality to find the length of time. So if you're looking at a rate and we're looking at a distance and we're looking for a time, what does that make you think of? It should make you think of D equals RT. The only thing now is that this is going to be an inequality because it's at least 9 miles. So if we flip this around to RT equals D, let's say that RT has to be, if it says it is at least 9 miles, this needs to be greater than or equal to the distance. If we plug in some numbers, R is 3/4. Time is T because we don't know, that's our variable. Greater than or equal to 9. So if it's at least 9 miles, I need to go at least 9 miles. I could go further. There's your equation. So write your equation. Solve the equation. How is it that we get rid of that 3/4 in front of the T? We multiply each side by 3/4. Nope. We multiply each side by 4/3. There we go. Multiply by 4/3. That cancels, leaving you with just a T. Since we did not multiply by a negative, it stays greater than or equal to. These simplify. There's a 3 and a 1, and we get greater than or equal to 12. And it's time, so it is going to take him at least 12 hours to walk to the lake. Okay, so if we have negative 3/5 D is greater than or equal to 6, and we want to try to get D by itself, how do we get rid of the negative 3/5? We are going to multiply by the reciprocals. We are multiplying by negative 5/3. Okay, because remember, any number times its reciprocal is 1, so the 5's cancel, the 3's cancel. A negative times a negative is a positive, leaving you with just D. And then because you multiplied by negative, we're going to reverse the inequality, so it becomes less than or equal to. And I'm just going to do a little bit of simplifying before I multiply. Negative 10. So D is less than or equal to negative 10 is your answer. Now I don't have specific directions on this slide, but keep in mind you do need to do whatever your directions ask. So in the case that it says check, let's review this. Remember that you always check 3 cases. You check a less than case, so a less than negative 10. You check an equal to negative 10. And we check a greater than negative 10. Okay. So what number less than negative 10 do we want to check? I'm going to go ahead and go with negative 15. And then equal to negative 10. And greater than negative 10, I'm going to say 0. So remember, you check in the original inequality. So this is going to be negative 3/5 times negative 15 is greater than or equal to 6. And this reduces, that becomes a 3. Positive 9 greater than or equal to 6. Is that true or false? That's true. Okay, and then we go on to have negative 10, so we're going to have negative 3/5 times negative 10. Okay, so again we're going to reduce. We get a positive 6. Is that greater than or equal to 6? That's also true. And then if we plug in 0, negative 3/5 times 0, remember you do need to show work on these. We're going to get 0 is greater than or equal to 6. That one is false. Okay, so there's our check. Notice that the two that worked are the true and the true. Yeah. The less than case and the equal to case are the ones that worked. And if you look over here, both those are in your answer, less than and equal to. All right, so then again, just based off directions, if it says to graph it, remember at least one number on either side. This one happens to be a closed circle on negative 10 because it has the equal to part. And then if we want all the numbers that are less than negative 10, you're going to do your arrow to the left. Those are your numbers that are less than negative 10. Okay, let's move on to the next problem. All right, so negative n over 6 less than or equal to 8. So we have to get n by itself. And how do we do that? We're going to multiply by negative 6. Multiply by negative 6, because 6 on top, 6 on bottom cancels. A negative times a negative becomes a positive. And we're going to get n is greater than or equal to, because I'm switching my inequality because I multiplied by a negative. And that gives us negative 48. So there is our answer. And then one more time, remember you check 3 cases. You check a less than negative 48. So this is our checks. You check an equal to negative 48. And you check a greater than negative 48. So a number less than negative 48, I'm going to check negative 54. I'm going to check negative 48. And I'm going to check 0. You can check with any number that you want to. Okay, so if we had negative 54, notice I had 2 negatives there over 6, less than or equal to 8, because I have my negative that it comes with and then the negative that I'm putting in. So that becomes a positive because it's a negative negative. 54 divided by 6 is 9. Is 9 less than or equal to 8? No, that's false. Okay. And then we're going to have a negative 48 over 6 less than or equal to 8. That becomes a 7. Nope, it becomes an 8. An 8 less than or equal to 8, is that true or false? That's true since it has that equal to part. And then 0, so we're going to have negative 0 divided by 6 less than or equal to 8. Well, 0 divided by anything is 0. Is 0 less than or equal to 8? That is true. Okay, so notice the two that worked are the equal to case and the greater than case. Those are the two that worked. Okay, and if you're asked to graph it, at least one number on either side of what you're graphing. This one is also a closed circle, arrow to the right, because that would be the numbers that are greater than negative 48. Okay, so why don't you pause the video and see if you can work this one out on your own. Okay, I get P is less than 15 halves for an answer. You can change that to an improper or a mixed number if you want to, but you can definitely leave it as an improper fraction. And then if you want to practice checking it or graphing it, you're welcome to. All right, so far all of our examples have involved multiplying both sides, but you might occasionally have to divide both sides. So 2 properties for dividing both sides. You can divide both sides of an equation by the same positive number and you're fine. But again, if you divide by a negative number, you must reverse that inequality. So as an example, if 4 is less than 6, which it is, if I divide both sides by 2, I get 2 is less than 3. That's still true. But if I take 4 is less than 6 and I divide both sides by negative 2, I get negative 2 is less than negative 3. But negative 2 is not less than negative 3. It's greater than negative 3. But if I reverse my sign, then it will work. So that's what you got to do, reverse your sign. Okay, so let's see if we can get s by itself. If we have 12s is greater than or equal to 60, how is it that we get s by itself? We divide by 12. All right. So s. Now, do I have any need to switch my inequality? No need this time because I didn't divide by a negative. So greater than or equal to 5. There's your answer. And I'm not going to check it, but you should know how to check it and graph it if you're asked to do so. Okay, so negative 8q less than 136. What would you do to get q by itself? Okay, we're going to divide by negative 8 both sides. So we're going to get q. Now this time we did divide by a negative, so we are going to reverse our inequality and make it greater than, and it's greater than negative 17. And again, you should be able to check it and graph it. All right, what about on this one? How are you going to get r by itself? Divide each side by 9. R, do I switch my inequality? No, because I didn't divide by negative. R is less than 3. All right, last one. Why don't you pause the video and see, make sure you can do it. Okay, and I got that g is less than or equal to negative 8. So remember to switch your inequality because you're divided by negative. So that's what 6.2 is about. You just need to remember the main difference between solving an equation and solving an inequality. If you divide or multiply by a negative, you have to flip your inequality. So let me know if you have any questions. We'll see you later.